Hello guys, in the previous video we have discussed about the mechanical applications, particularly electric field applied parallel to the plane. If the plane is horizontal, field is horizontal. If the plane is inclined, field is inclined. That means electric field is parallel to plane. But in this video we will discuss here plane is inclined but field is parallel. Here plane is inclined and field is vertical. So now let us discuss about first, this is number one, horizontal field. Horizontal field, for horizontal field. Now consider this object mass m, charge q. Electric field is from left to right, towards right. Okay? Theta is more than angle of repose. Therefore, any object placed over it, it has some tendency to move down with the force mg sin theta. So this is the mg. Now this is inclined plane. Here this is normal reaction. Okay? Now this is mg cos theta. Now in this section, normal reaction is taken into account because in the previous section E is parallel to plane. Therefore, it has no effect on normal reaction. It is neither supporting nor opposing. That means there is no component of E along normal reaction. Okay. Now, if this angle is theta, then geometrically this angle is theta. Therefore, component of E along this direction, this is E cos theta, and along this direction, this is E sin theta. Mark the difference. Okay. Now, this is electric field. If charge is Q, then you can take forces QE cos theta and forces QE sin theta. Okay. Now this is horizontal field. These two lines are parallel. This is intersection. This angle is E theta, then this angle is theta. Okay. Now resolve E into components parallel to the plane. Upward QE cos theta, then along the opposite to normal, this is QE sin theta. Okay. Now if this is the case, first you take, that is in equilibrium, N equal to, first you take normal, QE sin theta plus mg cos theta, you will get one equation, and this equation is fixed whether you take equilibrium or not. Okay, because the object has no tendency to move it towards space, nor it creates some hole along this direction. Now along this direction you take this direction as x coordinate, this direction as y coordinate. So along y coordinate normal reaction, along x coordinates. Okay, so you take QE cos theta, that equal to mg sin theta. This is the value. QE cos theta equal to mg sin theta. This is in equilibrium. That is, surface is smooth. This is the condition. Surface is a smooth. Okay. Now, if this is the case, then you find out what is electric field required. This is mg by q into tan theta. Electric field required in order to produce equilibrium. This is mg sin theta divided by q cos theta. Just you arrange, sin by cos is a tan. If q is asking, E is given, then q is mg by E into tan theta. How many number of charges or magnitude of electrons or positrons are there? Then n is mg divided by E. You can put q equal to me. Okay, that is q equal to, I am taking me, E is magnitude of charge of an electron. There are number of ways to calculate. Now this is the case. This is horizontal field towards right. Okay, horizontal field towards right in equilibrium in smooth surface. Second thing, that is in accelerated motion. Accelerated motion. Okay, suppose the object is moving along the incline, along upward with acceleration a. I am giving here some acceleration a. If it is moving upward along the incline, accelerated motion, here you take up along incline, then QE cos theta must be greater than mg sin theta. Therefore, difference of these two must be equal to mass into acceleration. Okay, so from this you find out A, that is QE by m cos theta minus g sin theta. So this is the value of acceleration. These are the cases if the surface is smooth. These are the cases if the surface is smooth. Okay. Now, if the surface is rough, then again question comes: in which direction the object has tendency to move? If the object has a tendency to move upward, means friction is along the direction of mg sin theta. Therefore, you take mg sin theta plus friction. Okay, I am writing just only one equation here, but not here. That is for rough surface. Okay, you write this equation for a rough surface. You write QE cos theta. This is forward force minus mg sin theta plus friction. Friction means that is mu into n, that equal to your resultant force. Okay. Now what is n? N is given. Then you put n equal to this value here and you can solve it. Therefore the equation will be little bit lengthy. Okay. Now this is all about the equilibrium accelerated up. Similarly, if you reverse the direction of electric field, accordingly you can calculate, or direction of field remains the same, but mg sin theta is larger than QE cos theta. Mg sin theta is larger than QE cos theta. Therefore, here you write first mg sin minus QE cos theta, that equal to mg. That means instead of body moving up, body is accelerating down. That means if you put this formula wrongly, you will get A equal to minus. A equal to minus means if you give this is the direction of A, suppose the value comes as a minus, that means your direction, along your direction the object is not moving. The object is moving opposite to your direction. Okay. So therefore you write QE cos or mg sin minus or interchange, nothing. If A is positive, then direction is up. If A is negative, direction is down. Okay. Now this is all about the horizontal field. Now let us come to the vertical direction of electric field. Okay. Now this is object of, you take mass and charge q. So this is the direction of electric field along vertically upward. Okay. Now that is weight direction is mg. Like previous case, this direction is mg sin theta, and this is your normal. Okay. This direction is mg cos theta. Now angle between, mark, angle between direction of electric field and theta, this angle is 90 minus theta. By geometry, if this is angle theta, this angle is 90 minus theta. Okay, these angles are same as per the geometry. Therefore, E makes an angle 90 minus theta with horizontal. So what is component of E along this direction? Okay. Vector E, electric field, makes an angle 90 minus theta with the horizontal. Its component along this direction is E cosine 90 minus theta, that means E sin theta. And its component along perpendicular direction means along normal is, this is E sin 90 minus theta, means this is E cos theta. If you multiply with Q, then this is your force. Therefore, force due to electric field is QE sin theta along the incline, and QE sin 90 minus theta or QE cos theta along the normal. Okay. So now that is first case, vertical field. This is vertical electric field. Now first, in equilibrium. In equilibrium, I am taking surface is smooth surface. Okay. In equilibrium, first you take QE cos theta plus normal reaction. This is mg cos theta. So therefore N, this is mg cos theta minus QE cos theta. Okay. This is the first equation. Then comes to the second equation. Along up, this is QE sin theta. QE sin theta. Along down, this is mg sin theta. That means QE equal to mg. So E equal to mg divided by Q. This is the formula. Okay. So if the field is vertical, object is somewhere here. In order to produce force is EQ, weight is mg, exactly you will get the same formula. Okay. So now here you take this direction as y-axis and this direction as x-axis. Along normal component y, along inclined plane, if you take x, then you write one equation along x coordinate, another equation along y coordinate. If the surface is smooth, the situation is like this. Then again another point you come. Suppose motion is accelerated. Motion is accelerated. Surface is smooth. Okay. I am not taking the rough surface, because if the surface is rough along the opposite to direction of motion, you can add a force, that is friction, mu n. Okay. Now accelerated motion, suppose smooth. Now the field is applied along this direction such a way that the system, that is mass m, if it moves along a, like previous problem, if it is accelerated up, okay, if it is accelerated up, then this is greater than this, that means QE sin theta minus mg sin theta, that must be equal to your ma. If a equal to positive, that means body is accelerated up as per your given data. If a is positive, then direction is okay. If a is negative, then body is moving down. So I am not writing accelerated along the incline or down the incline. You take first along the incline, that is a. If a is positive, from this equation, if you will obtain positive value, its direction is okay. If it is negative, then reverse the direction. That means body is sliding down. So this is your equation of motion. And if you want to take, suppose A is positive, presence of friction. A is positive. Second, another point, that is friction. I want to take A is positive. That means body is moving up. Then you take QE sin theta minus mg sin theta plus mu n, that equal to ma. This is your value. Just you add Friction means mu into normal reaction to mg sin theta. If the body is moving down, you add mu into qe sin theta. Okay, what is n? N is given in equation 1. Its value remains same. So this is the cases in the presence of electric field. If you are able to get acceleration in all cases, then you can calculate kinematic properties and dynamic properties. Similarly, if the body displaces from this point to this point, suppose this is the height travelled by the body, this is the distance travelled by the body, angle theta remains the same. So how can you calculate the work done? The work done means potential energy, mgh. Potential energy is mgh. You find out the value of h here. To find out the value of h, you take work is resultant force. This is qe sin theta minus mg sin theta. This is the resultant force means ma. Okay, into s. S means this is. Okay, now instead of s you express that is sin theta, that is equal to h by s. So what is h? H divided by sin theta. If you put that, you will get potential energy. Similarly, if the body start from rest, motion is accelerated, and here velocity is a v, then you can calculate. Okay, the its kinetic energy or change in kinetic energy. Okay. Now, similarly, just I will give you some hints to calculate these properties. Suppose here mass is m1, here mass is m2, charges are q1 and q2, or charges are suppose equal qq. Okay, charges are, or you take q1 and q2. Now, electric field is along this direction. Electric field is along this direction. So this direction is m2g and qe, q2e. This direction is m1g and this direction is q1e. Okay, suppose we observe that this is the direction of electric field. If we will observe in this pulley system, suppose m1 is moving up with acceleration a, m2 is moving down with acceleration a, then for m1 you write m1g plus q1e. This is tt. T minus this, then equal to your m1a. Okay, t is forward, this is backward, t is greater than this, therefore this is m1a. For m2 you write m2 is moving down, q2e plus m2g minus t, that is equal to m2a. Now, if you add these two equations, you will get simply by adding, you will get tt cancelled. Okay, so this equation is m1 plus, that is m1 minus m2 into g, one term, then q1, that is q2 minus q1 into e, another term, q2 minus q1. Okay, m2 minus m1, this is m2 minus m1 into g, q2 minus q1 into e. This is equal to a into m1 plus m2. So what is a? Equal to m2 minus m1 by m2 plus m1 whole into g plus q2 minus q1 by m2 plus m1 whole into e. So in this way you can calculate the values of acceleration and the other properties can be calculated. Okay, if you like this video, subscribe it, comment it and like it. Thank you all.